Hi, right now we want to talk about problem solving with C++, 10th edition, Savitch, and we're going to be talking about section 3 of chapter 2. That's data types and expressions. So that's what we're talking right now. So to start with, we have talked about integers and we have talked about double. So there is a difference between the numbers that have no decimal point and the numbers that have decimal point. So the question that creators of C++ were asked is, if we don't need the decimal points, should we reserve some space in the memory for it? And they decided that they're going to separate them and they're going to have the integer with no decimal point. So it's going to be a smaller size in the memory. To be efficient. So C++ has been an efficient language, and that's one of the reasons for this. So we're talking about the int that doesn't have no decimal point. It can be positive or negative, including 0 with no decimal points. And then we are using double over here, which I am used to float, which is a half of the double size for the things that we're doing for this class, but that's okay. We're going to stick with the book suggestion and we're going to go with double. And double is a number with a decimal points. So it can be any number, including the whole numbers with the decimal points. One thing that we want to pay attention here in this section is the E notation. The E notation is a scientific notation, and the scientific notation is just like in your math, you are using 10 to power of something. So for example, in this case, 5.89 e to the minus 6 is the same in the math that would say 5.89 times 10 to the power of negative 6. So negative means your decimal point is going to move to the left 6 times. And if it was positive, your decimal point would have moved to the right 6 times. So the default for C++ is scientific notation. That means if you don't say anything, it's going to display things in scientific notation. So something like this, 367 with a bunch of zeros after it, or 0.0589 with a bunch of zeros before it, is going to be shown in a scientific notation. That's a default for C++. So it goes to the memory, and I'm talking about how C++ is efficient in that area. I have talked about this in the previous section. Of course, because we have a limited space, if our number goes outside of that memory space, then we're going to have a problem. C++ does not check that, so it goes over some other stuff. So we talk more detail about these things later. These are the sizes that they are using in memory. I don't want you to memorize this, but just a reference that you can always go back to it. This is done in 32-bit. So int is something that can potentially change with the size of the computer. So size, I'm talking about the word, means that when you say 32-bit, 64-bit, that's the size of your word, which is the instruction is that big. Again, you don't have to worry about these things too much, but that's what it is. Your instruction is that big, your things are going to be that big. So the int here is 4 bytes, that's 32-bit, and that's the size of the int. And because it's using a negative sign, it's using the it depends how you look at it, the first bit or the last bit all the way to the left as a sign. So that's what it's using, and that's why the number is going to be much cheaper. It's cheaper, smaller, meaning that if I have a 4 byte, 4 times 8, 1 byte is 8 bits, that's going to give me 32 bits, but we are actually using 31 bit because we're using 1 for the sign. Again, not a big, huge thing for now, and we talk about it when we need it, if we need it. So you can see that the float is smaller than double, it's half a size. And for a lot of programs that we are using, float would do the job. But for some reason, your author want to use double, and we're going to stick with that. And of course, if the double was not enough, we're going to go to the long double. So for the things that we're doing in this class, we're just going to use int and double, and we are not going to be worried about the rest of this stuff. So again, if you want longer one or bigger numbers, you can use long. If you don't need that long, you can use short. Short would be a much smaller one to use. We used to spend a lot of time thinking about these things because the computer systems that we had were much, much smaller than what we have today. So for example, the first computer I put together back in 90s, I only had 256K memory. That is a quarter of a mega, 1 mega. So it wasn't even 1 million. It was a quarter of 1 million. Right now you're talking about getting a computer with 200 megabyte hard drive and those kind of things. We only had a quarter of a meg for our memory. And that by itself cost $1,000 at the time. So you can see how things has changed. So we are not worried about it as much, but as a programmer, as a software engineer, you want to be conscious about it. So if I have a program that only works with a small number, then maybe I want to use short. And if I know I'm going to have a longer number, the danger with that is if I don't think about it, then it can potentially give me some wrong answers because it's going to go outside of its limit. Of course, if you're working with a smaller footprint, like cell phones or device drivers, then you might be a little more conscious about your memory management and those kind of things. So we could use potentially float. If you want to use it, more than welcome to use it. And you can define it as a float, smaller one. And then we have something called the char, for character. Character is 1 byte. That means it's going to hold 8 bits. In C++, you can use that to store your numbers. That goes from 0 to 255. That's 256 combination. So if I know that I have only my number only goes up to 256, then I don't need to use int. Remember, in here, we were talking about 4 bytes, and sometimes we're talking about 8 bytes for int. So if I'm conscious and I don't want to do that, I can actually use char for my numbers, but we get there soon. So characters are, we're going to be using single code. So for the character, it's going to be a single code. And single code means 1 character, which is 8 bits. So if I want to draw, let me see if I can draw. So if I have 1 byte, let me see how good I am in this. 1, 2, 3, 4, 5, 6, 7, and I need 1 here for 8. So that is 1, 2, 3, 4, 5, 6, 7, 8. That's 1 byte, which is 8 bits. So 1 character is going to hold in 1 byte. Now, if I use a string, which is a double quote, the double quote string always needs to terminate with \0. So there's going to be \0 at the end. So in a string, I have A and I have \0 on it. So it's going to be 2 bytes, 1 byte for A, 1 byte for my \0. in my character, I only have A by itself. It does not have anything after it. So there is a big difference between a string and character, and especially when we're comparing things, when we want to do things, then it's going to be different. So we got to be mindful. There's a few things in C++ we have to be careful about it, and there is the difference between a character and a string, something to watch out for. So C++ 11, one thing about the C++, it is a universal language. And when they want to do any kind of a change, they want to get a feedback from everybody, go over it, go back and forth, and create some standard that works for everybody. And with this book, we start using C++ 11. This was created at 2011. Now you see how much we are behind this stuff. So in C++ 11, which all of you are already going to be using in this class because the newest compilers, they're all C++ 11. If we go to display 2.3, you can see they're going to be a lot more specific of what do we want to use. So again, we can think about 1 byte with sign, or we can use 1 byte without sign. So if I go back to the picture that I have, that would be one, two, three, four, five, six, 7, and 8. So if I have 8 bits, remember, computer only understands zeros and ones. So I only have zeros and ones over here. But we're going to keep the last one for a sign. So this is going to be either 0 for positive, or it's going to be 1 for negative. That means I'm going to be using the rest of this for my number. So if I count this, the combination that I can have, 0, 0, 0, 0, 0, 0, all the way to 1, 1, 1, 1, 1, is going to be 255 combination. So including 0 is going to be 256 combination. So if I don't use this for a sign, I can have 0 to 255 as a number. But if I use this as a sign, then I don't have 8 bits anymore. I only have 7 bits that I can work. And you can see my number is going to be much smaller. And that goes on for the rest of the numbers, that if I reserve this for a sign, then my number is going to be much smaller. So the question sometimes is going to come in that, do I really use sign for this? And if my numbers are all positive all the time and I don't need to use negative, then maybe I use unsigned instead of sign. Again, it's about the efficiency. It's about how we're going to do these things. And again, you don't have to memorize this, just to know that does exist, and you can refer back to it whenever you need it. Okay, now, if I want to use my cin to read a character, remember what we talked about before. The cin, the extractor operator, is going to skip over white spaces. White spaces are space, tab, and a new line. So it's going to read the first character because we define it as a character. And whenever we're using cin with the extraction operator, what's going to do is going to read whatever it needs to read, and it knows because it knows the size of it, and it's going to stop right there. So if I am reading 2 characters and the user puts 2 characters, what's going to happen is first, it's going to be pointing right here. When I do my first cin, it's going to read this character and it's going to stop right here. My next cin is going to go over the spaces and then it's going to read this. So putting it next to each other like this, or have some spaces like that, or even if I put it in different lines, I could easily do it I could easily do it as J and D, or I could even say J space, enter, space, D. All of these entries are going to give me the same result. I'm going to have J on my first variable, and I'm going to have D on my second variable. The extraction operator is going to skip over spaces, it's going to skip over tab, it's going to skip over new lines. So let's take a look at sample code for this. So this is a sample code. We have 3 characters over here, and I strongly suggest you guys run this in your free time and see your output and try to modify it and figure it out. So in here is asking for 2 characters. It's going to read 2 characters, and then it's going to print it, and then it's going to use the third one to create a space. So it's putting a space on the third character. This, remember again, if you're using 1 character, it's going to be single code. It's not a double code. Now it's going to print the first one, print the space, print the second one. And that's the way it's going to happen. One thing that I want to show you here is even though you read this, so the user put J and put a space and put B, when you read it, the first character and second character is going to go into each one of them. So when you display them, there is no space between them. So that's why we have to manually put a space between them. There is another thing that's going to come up that's called string. A string, again, is more than 1 character. So we have char for character, and we have string. We will play with these things. Your book is not using a string as much till we get to later chapters, but we just throw it in there once in a while and figure it out. And as you can see, a string was, first of all, a string was not part of C language when I was writing C language. You remember C was before C++. C++ was object-oriented for C. So they created this library for a string and they brought it in. So every time you're using a string, you gotta use pound include string. And then you can assign things to it, and you can add them together. You can do a lot of things. A string is addressed in chapter 8, but I definitely want to go over it much sooner than that because it helps a lot to do a lot of work. So, for example, here I can read some names. Again, if I'm using cin, it's going to stop on the space or a new line or tab. So if I put the names like this, it's going to read this. It's going to read the first one, and it's going to stop right here. And then the next read, the second one, is going to skip over spaces. It's going to read this, and it's going to stop right there. So that's the way that your cin works. So this is the end of this section. I want you to go over this. Be sure that you're ready to talk about it in the class. And that's when we meet it in the class, we can go over this, or any other questions that you have. You can either put it in a DQ or just bring it to the class and we can talk about it.